Hey guys, in this video I want to go ahead and talk to you about matrices and actually solving for a matrix and using the inverse matrix. Now there's one thing we've talked about: multiplying matrices, adding, subtracting matrices. The only one thing that we cannot do with matrices is divide them. And the way you solve matrices, instead of dividing, you use what's called the inverse and the inverse operation. So think about it this way: you have, right, like an equation, 3x equals 6, whatever. So you would normally divide, right? Well, division is the inverse operation. Well, so the inverse here, if you remember, is a to the negative 1. That's the inverse operation of this equation, okay? So that's what we're going to be doing. And the inverse for a matrix is going to be a, capital A, to the negative 1 power. Okay, and the thing about the inverse, one thing you have to understand is when you have the inverse times the original matrix, it's going to give you the identity matrix. Similar to, how when you multiply C times 1 is equal to C, the identity matrix is at 1, okay? Or remember how, for example, like 1/3, right? The inverse of 1/3 is the reciprocal is 3, and that's going to give you a 1. So that's what we call it, the multiplicative inverse, okay? So the identity matrix is always a square matrix, and it looks like this. So when you multiply out your two matrices, they should give you something that looks like this. And they're always square. You see this is a 2 by 2. This is a 3 by 3. And then you notice there's a 1 along the diagonal here, and everything else is 0. So we call this the identity matrix. So if your professor starts talking about that, you understand what that means. So here we have two matrices, A and B, and we want to verify that they're inverses of each other. So what we go ahead and do, we're going to multiply these out. Remember, row times column. So row, first column. So 1 times 5 is 5. 4 times negative 3 is negative 12. First row, first column. And then on the bottom, 3 times 5 is 15. 5 times negative 3, negative 15. And then first row, second column. 1 times negative 4, negative 4. 4 times 1 is 4. And then second row, second column. 3 times negative 4, negative 12. 5 times 1 is 5. And then when you do the math, you get negative 7, 0, 0, negative 7. Well, to change it into an identity matrix, you would have to divide by negative 7. Everything divided by negative 7, and you end up with the identity matrix. And that's the essence of finding the inverse of a matrix. So I'm going to show you guys quickly. I'm going to show you kind of the long way, how we set it up, and then I'll show you the fast way. Okay, guys? So we have this matrix A. We want to find the inverse. So essentially, this is what's going to happen. You have A, the matrix A times some matrix, okay, X. That's what we're trying to find out to make it into an identity. Because remember, the inverse times, remember, the inverse times the original is going to give you the identity. So what we're trying to find is the inverse. They give us the original matrix, okay? So we're trying to find out this guy X, which represents the inverse. So we have this, and this is what we're trying to figure out, and it should give us the identity matrix. Well, if I solve it like I normally do, right? This is A, B, C, D, because I don't know the values. So 2A, and then plus 3C is equal to 1. First row, first column. First row, first column right here. And then the next one goes second row, first column. 1A times negative 1C is equal to whatever this guy's here in the bottom, which is 0. First row, second column. Second row, first column. Second row, first column right here. And then same thing here. First row, second column. So 2 times B plus 3 times D. And that represents this corner over here, which is 0. And then 1 times B minus 1 times D represents this bottom corner. And essentially, you would use your math to solve the system, and you would do it that way. But there's a lot quicker way, which a lot of people know and they utilize. And if you notice the inverse, and let me show you guys something real quick here. All you got to do to find the inverse, guys, okay, is this. I'll show you this. Here's our original. What you're going to do is you're going to switch the position of these two. Okay, the top left corner and the bottom right corner. So you're going to switch these two. So the 2 is going to go down here, the negative 1 up here. And then these two, the 3 and the 1, are going to become opposites. So instead of a positive, it becomes a negative. Positive 1 becomes a negative 1. And that's part of the inverse. But the other thing you're going to have to do is you're going to have to multiply it by what we call the determinant. And if you don't, you see how I got this guy over here, negative 7, right? Well, in order to make it an identity, I have to divide everything by negative 7. Well, that negative 7 comes from my determinant. Well, how do you figure out your determinant? Your determinant is that scalar value that you're going to multiply in order to make it into a identity matrix. So here, this is the original. I guess you can call it formula. So what you're going to go ahead and do, guys, this is your original matrix, right? Your determinant is 1 over, you start up here, A times D minus C times B. Okay, you just kind of do this part. This times this minus this times this. Okay. The only thing you got to make sure the bottom, the denominator, does not equal to 0. Because if it does equal 0 on the denominator, then it's invertible. You can't figure out the inverse. Okay. Now, right here it says CB, and right here I put BC. It means the same thing. Remember, multiplication is commutative. So A times D minus this times this. Okay. And so here, when I figured out the determinant of this guy, okay, I switched these two values. Okay, I got this part. That's the easiest part. Now I got to do the determinant. Well, I do the original. So 2 times negative 1 is negative 1 minus, and then 1 times 3. And that gives me negative 1 over 5. And when I do that, I should be able to go ahead and get my inverse. All right, guys. So let's go ahead and see if we can go ahead and do a few examples here. Okay. So the first thing we're going to go ahead and do is find our determinant. Okay. Well, let's go ahead and see. 1 over, and then 4 times 3 is 12. And then negative 1 times 2. So be careful, you're going to have that double negative. Okay. And now, all I got to do is switch these two. So the 3 comes up here, and then the 4 goes down there. This 2 becomes a negative, and then the negative 1 becomes a positive 1. There it is. And then on the bottom here, you get 1 over 14. Okay, and then you get 3, 1, negative 2, and 4. All right. And so now that becomes the inverse. So the last thing you got to do is just distribute this 1/14 into everything on the inside. So the inverse is 3 over 14. And that becomes negative 2/14, which is negative 1/7. And then this becomes 1 over 14. And then becomes 4 over 14 becomes, would that divide by 2? 2 over 7. Okay. And there it is, guys. That's the inverse for this matrix. Okay, and then when you multiply this guy and this guy, you would get the identity matrix. All right. So this only works for the 2 by 2. There's a way to do it for the 3 by 3, but we'll work on that next time. So let's do this inverse of this guy. So 1 over, start on the top left hand corner. Do this guy. 6 times 1 is 6 minus, and then negative 3 times negative 2 is a positive 6. And what do you notice? We end up with 1 over 0. So what does this mean? It's invertible. We can't find the inverse of this guy. Okay? Why? Because the denominator is 0. Okay? So we can stop there. Let's do one more. And this is matrix B. Let's find the inverse. All right. So let's go ahead and do this one. So 1 over 4 times 7 is 28 minus, and then negative 3 times 2 is negative 6. Okay, and then we're going to go ahead and just switch these two up. The 7 is going to go up here, the 4 down here, and then the negative 3 becomes a positive, the positive 2 becomes a negative. And then we get 1 over, looks like 34, and so now we have 7, 3, negative 2, and 4. And now what do I have to do? I just have to go ahead and distribute that to everything on the inside. So that becomes 7 over 34, and this becomes 2 over 34, which is negative 1 over, what is that, 17, and then 3 over 34, and then you get 4 over 34, which becomes 2 over 17. All right, and there it is. All right. Now let's say I want to go ahead and double check that. Let's go ahead and use your calculator just real quick here. All right, turn that guy on. Had my matrices, so go to second, and then you're gonna go to matrix, which is under that right there here. All right, we're gonna go to edit. We're gonna edit. We'll just call it. I'll do matrix A. So we'll do this one. So if this is a 2 by 2, so this is a 2 by 2. All right. So 4, hit enter, and then 2, hit enter. -3, hit enter, and then 7, enter. All right. Quit that out. So let's just double check, make sure I have it right, and there's matrix A. Hit enter, and yep, that's what I wanted. So now what I have to do is I want the inverse, right? So I hit A to the power. This is, guys, a little to the power right here. And I'm going to put -1. So you're going to go ahead and use this guy here. And let's delete that. And actually, I didn't need to do that. But you can either do here, or you can put the -1. And you see it gives me these decimal values, which coincide to these values right here. So that's a quick way of using the calculator, which is nice. If you want to figure out 7/34, you see I got the same thing. So it works. So guys, hopefully that's not too hard. Pretty simple, pretty quick and easy. So this is only for a 2 by 2 matrix. Okay, guys? All right, so hopefully it makes sense. See you guys next time.